Hello, beautiful people, and welcome. In today's video, we are going through the Chapter 6, Are You Ready packet. Let's go ahead and get started. Reminder, I am human, so if I make a mistake, please let me know where the mistake occurs so that way I may learn from it. Let's start with question number 1, which is our exponential properties. Remember, you have to have those memorized and basically know what to do with them. Let's go and start with A. So step number 1, you're going to be splitting everything up with a multiplication dot between all of your factors. So you're going to write 3 times x times y times x to the fourth times y to the fourth times 4 times x times y cubed. Now, if there is anything, any variable, any letter without an exponent, we're going to place that, or I guess make it show by placing a 1 as our missing exponent. Next, you're going to rearrange things. So I'm going to put my numbers like 3 and 4 next to each other. 3 times 4. I'm going to put my letters next to each other. And my letters x are going to be next to each other. X. And I'm taking the exponent with it. X. And then I'm going to be writing my y's. So again, this step, we are just rearranging as so. Okay, now that you have step number 1, split everything up, split up the factors. Step number 2, rearrange the factors. Step number 3, you're going to use the exponential property to condense. We're going to make things smaller. So the exponential property states that if you have multiplication between the same base, x, and x, we get to add the exponents together. Okay, so these are going to be pluses and pluses. Again, if the base is the same, like y, and y, we're going to add the exponents together. Now, things like 3 and 4, this is just regular multiplication between numbers. This says 3 times 4. So to continue, let's go ahead and do 3 times 4, which is 12. Just regular multiplication. This needs to be condensed, so we're going to write just x. We're going to add the exponents together, so we got 1 plus 4 plus 1, which is 6. And we're going to condense. We're going to put these together just with a y, and now we have 1 plus 4 plus 3, which is 8. Now you can leave these multiplication dots here if you'd like. You do not have to. You can remove them. For our next property, we have our power to a power with a product. What that means is step number 1, you're going to split our factors up. So we got 4 times n squared with that power of -3 on the outside. Next, we're going to put parentheses around 4 and around n. So the way that I like to say it is if it's in a bubble, if it's in parentheses, it's going to get its own bubble, okay? It's going to have its own parentheses. So if it's in a bubble, it gets a bubble. If it's in a bubble, it gets a bubble. And if it's in a bubble, it gets a bubble. We still have that -3 as an exponent. And notice that there is no exponent on 4. Now, when you're using this property, you do want to put in any missing exponents, even on numbers. So I'm going to put in a missing 1 exponent on top of 4. Next, we're going to apply the property. Now, this property is a power to a power, an exponent with an exponent, and that means we're going to be multiplying times these exponents together. So I'm going to write this out a little bit of a longer way. So we're going to have 1 times -3, and we're going to have 2 times -3. So that means for our answer, we get 4 1 times -3 is -3 times 2 times -3 is -6. Now, I said for our answer, which is incorrect, because this is not our answer. It looks like we have one more property to use, and that is because we see a negative on our exponent. Negative. When you see a negative exponent, first of all, that means you're not done, but it actually means that you're going to be taking the reciprocal of the base, or what we call flipping the base. So that means this is going to go on the bottom, this is going to go on the bottom. It looks like I am running out of space, so I'm going to write my answer on top. So it looks like I'm going to have nothing on top, so I'm going to put a 1. Nothing on top, I'm putting a 1. But on the bottom, we're going to have 4 to the third power times n to the sixth power. Now they are positive because we ended up evaluating this negative, right? What we did is we said negative means we flip. So when we do flip, it becomes a positive. Now it does take one last step to evaluate this 4 to the third power. 4 times 4 is 16. 16 times 4 is 64. Make sure you have that memorized for your answer. So I'm going to draw a little line here and an arrow so we know that that's the answer. Okay, let's move on. Here we have a quotient property, meaning division. Step number 1 is the same as we've done before. We're going to split everything up. So we have 3 times x times y squared over 4 times x to the fourth power y cubed. When we apply the quotient property, you have a choice to make. We have number and a number, so we can put 3 and 4 on top of each other. But notice that 3 and 4 are not the same number, so we cannot apply any properties to it. This is just regular division. Next, we have x and x. Those are going to be on top of each other. And y over y. Notice that my x does have a missing exponent, so I need to put a 1 as a placeholder. The quotient property says that we are going to take the top exponent and subtract it from the bottom exponent. So I'm going to have 3/4 times, so I'm going to do my line. We have top minus bottom, top minus bottom. Some of you are choosing to skip this step, which means you're getting your answers wrong. Please don't skip this step. Top is 1, bottom is 4, top is 2, bottom is 3. Again, we still have our 3/4. 1 minus 4 is a -3. 2 minus 3 is a -1. So again, notice how we ended up with negative as our exponent. So that means we will be flipping the base. And again, I am running out of space, so I'm going to have to write the answer up on top. Also, take a look at that 3/4. 3/4 here cannot be simplified. This is just regular division, so if you can simplify that fraction, you must. And I'm going to draw an arrow here. So what do we have? We have 3 on top, 4 on the bottom. Our x is going to be on the bottom as well, x cubed, and our y is going to be on the bottom as well with a positive 1. This here is our answer. Noticing how I'm running out of space already on these questions, I am going to be doing the remainder D and E on a separate sheet of paper. I would recommend you do the same. And then we can go back and write our answers on the actual worksheet. For D, the question is open to a to the -4th power, b to the -1st power, everything to the 3rd power. In our denominator, we have a to the 4th power, b to the 3rd power, raised to the 2nd power. Same as before on the other one, step number 1 is going to be separating things up, splitting everything up. So anything that we see, any factor that we see gets a, any factor that we see gets a multiplication symbol. Right now, we're still keeping things in parentheses. For the next step, we will be separating things out. So remember how to separate things. If it's in a bubble, it gets a bubble. If it's in a bubble, it gets a bubble. 2 gets a bubble. A gets a bubble. Oops, to the negative fourth power, almost forgot. And B gets a bubble. A is also inside parentheses. And B is also inside parentheses. Now be careful here because what parentheses they are attached to, what exponent they are attached to, they're different. So for example, our 2AB, all have an exponent of 3. However, our AB in the denominator have an exponent of 2. This goes back to our our power to a power property. If there is something missing, like there's this 1 on 2 that's missing, we're going to put in a placeholder. And then what do? We are going to be multiplying our exponents together. So 1 and 3 gets a multiplication, negative 4 and 3 gets a times, and negative 1 and 3 gets a times, as well as 4 and 2 gets a times, and 3 and 2 get a times. Let's go ahead and multiply these out. 2 is our base. 3 times 1 is 3. A is our base. Negative 4 times 3 is negative 12. B is our base. Negative 1 and 3, that is negative 3. A is our base. 4 times 2 is 8. B is our base. 3 times 2 is 6. Next, you have a choice to make. You can immediately evaluate 2 to the third power. 2 to the third power is 2 times 2 times 2, which is 8. So we can absolutely evaluate this as 8, or you can keep it and do that later. It's up to you. I am, however, going to be splitting things up. So we got A's over A's and B's on top of B's. Next up, we use our quotient property. Our quotient property is where we're going to do our top minus bottom. Please do not skip the step of writing this out. Please do not do this in your brain because of double negatives. So what it looks like is, here's our 8. We have a bar. Here's our division bar. We're bringing up our A by writing top minus bottom. Here's our division bar. We are bringing up the B by writing top minus bottom. So for our A, our top is negative 12, our bottom is 8. For B, our top is negative 3, our bottom is 6. Next step is writing it out. After you do the subtraction, keep your bars, so keep the division bars until you are ready for an answer. So negative 12 minus 8, that is a negative 20. Negative 3 minus 6 is a negative 9. Because my exponents are negative, that means we will be flipping the base. If it is not negative, do not do this step. So that means we're going to be taking B to the 9th, bringing it down, A to the 20th, bringing it down. 8 is just 8. There's nothing for us to do with 8. So 8 is on top. Positive A20 is on the bottom, and positive B to the 9th power. So if we were to multiply straight across, we would end up with an answer of 8 over A to the 20th power, B to the 9th power. Okay, moving on to A, B, C, D, E. And we'll go back and write our answers here in a moment. For E, we have open 2, U, V cubed. Make sure your U has a tail. Make sure V has sharp corners. Next, we have in the denominator, open U to the negative 2 power, V to the 4th power, close it. This is raised to the negative first power times 2u squared v squared. Step number 1, you're going to split everything up. So all over your factors here get a multiplication dot. Going to make this one a little bit longer. 2 to the negative u, sorry, u to the negative 2 power times v to the 4th power raised to the negative first power times 2 times u squared times v squared. It's very important for you to break everything up. Next, anything with a bubble gets a bubble. Now notice this 2, u, and v, there is no exponent on the outside of that parentheses. So yes, we're still going to give it parentheses around everything, but there is no exponent. So please don't put any exponents on your numerator. So 2, u, v. Again, no exponent extra, just v has the cubed. Here, u gets a bubble with a negative 2. V gets a bubble with a 4, and this one does have an exponent on the outside of the parentheses of negative 1. So that means my u to the power of negative 2 and v to the power of 4 both have an exponent of negative 1. Then we have 2 times u squared times v squared. An exponent with an exponent, the property is multiplication. We are going to be multiplying the exponents together with a power to a power rule. Here for my numerators, there's not really anything to do, so I'm going to drop my parentheses. Negative 2 times negative 1 is a positive 2. 4 times negative 1 is a negative 4. Now here you have a choice. You can split up your fraction as a quotient property. I don't recommend that. Instead, I'm going to condense and make this smaller. So I'm going to rearrange the denominator. I'm going to put u next to u, v next to v. So u and u get together, v and v get together, and I do have a 2 that I'm going to put in the front. The reason I did that is because now that we have the same bases, like u and u being multiplied, I can use my property to add the exponents together. I can only do this if the bases match. So u and u can be added for the exponents, v and v can be added in the exponents. We haven't really done anything with our numerator. We just copy the top. Here I am adding 2 plus 2 is 4. Negative 4 plus 2 is a negative 2. Now we can split up using the quotient property, 2 over 2, u over u to the 4th, and v cubed over v to the negative 2 power. Notice my numerator of u is missing an exponent, so I'm going to put in an exponent of 1. And then proceed with our quotient property. The 2 over 2, I am going to write that down. This is basic division. This is just 2 divided by 2. For the u's, we are going to do top minus bottom. And for the v's, we are going to be doing top minus bottom. On top, for u, we have 1 and 4. For v, we have 3 and negative 2. Be careful with that double negative. 2 divided by 2 is just 1, so you can keep 1 on top, 1 on the bottom. You don't have to. I am going to do that just for a little bit. U1 minus 4 is a negative 3. Double negative gives us a positive 3 plus 2 is 5. Because I do see a negative exponent, that means I'm going to be bringing down, flipping the base. 1 is just 1. Again, you can just omit 1 because we are multiplying. V to the 5th power is left over on top in our numerator. U to the power of 3 positive is in our denominator. All right, as promised, I am going to go back and write in our answers for E and D. So for E, our answer was V to the 5th power over U to the 3rd power. And for D, our answer was 8 in our numerator, A to the power of 20, B to the power of 9 in your denominator. Right, I am going to be going back to our worksheet here. The next thing it says for number 2, identify the following exponential functions as exponential growth, exponential decay, or neither. Okay, so it's going to be one of these. To determine if you have exponential growth or decay, you're going to take a look at your B value. You're going to take a look at your B value. You're going to take a look at your B value. If B is greater than 1, if it's bigger than, it's going to be growth. If it is smaller than 1, between 0 and 1, it's going to be decay. When you are determining growth or decay, you're also going to glance over at your A value, but not really your A value, at your positive or negative A. If we have a negative value here, immediately your answer is going to be neither. And that's because of this negative. If it is not negative in the front, no reflection across the x-axis occurred. So then we only look at the B values. Okay, B looks at the positive or negative. If it is negative, the answer is neither. If your B value, look at what we have 5, is greater than 1, it is exponential growth. And yes, I would like for you to write the word exponential. And if it's 1/5 less than 1, so it's smaller than 1, we're going to write exponential decay. And then yes, please write the word exponential in your answers. Right, moving on. Number 3. In number 3, it's asking you to identify the asymptote. So the asymptote is going to be your K value in your exponentials. And you're going to formulate it as y equals whatever number you have for K. So asymptote is going to be y equals, asymptote is going to be y equals, and asymptote is going to be y equals. Let's start with this one. We're just going to look at the very end of our exponential equation, and we're going to pick up our K value. We're going to take a look at the very end of our equation, our exponential equation, and we're going to pick up our K value. Now here, there is nothing there. However, there is, based off of the parent function, an exponential equation must have an asymptote. So if there is no asymptote shown, there is still one present, and that is at 0. Okay, moving on to question number 4. Describe the transformation from 1/3 to the power of x onto g of x. Okay, so what that means is this is our parent function. And as we discussed in class, we don't really care about the parent function. I care about you. You are my students. So that is what I am going to be describing. I'm going to be describing the changes that happened. I'm not going to be describing the parent. Describing also means that we're going to be writing in English. Your answer is going to be in English. These are going to be descriptors of what is happening when we graph the function. This 2 out in front is your A value. This is bigger than 1, so this is going to be a vertical stretch by 2. For your 1/3, we're just going to take a look if it's going to be a growth, decay, or neither. Since I do not see a negative out in front, that means this is going to be a decay, an exponential decay. We're going to take a look at our H value. Remember, this one on top is the only one that is opposite of what you see. So that means I'm going to go right by 1. And then this -4, your asymptote value, is going to shift down 4. Okay, let's try again. I do see a negative out in front. That means I'm going to have a reflection across the x-axis. I see a 1/5 in the front. This is not your B value. This is your A value. And because it is smaller than 1, this is going to be your vertical compression. You can also say shrink by 1/5. That 1/3 is your B value. So I'm going to be taking a look. Do I have a negative? Yes, it is negative, not the B value, but the function itself. And because it is negative, combined with our B, this is going to be a neither. That means there has been a reflection across the x-axis. So it will not look like a growth. It will not look like a decay. It will be something other than that because it will be a neither. Next up we have is our H value. If it is on here with an exponent, this is opposite of what you see. So I see a plus. That means I'm going to be going left by 3. And the last one I have is our asymptote value, this 2. That means I'm going to shift up 2, or you can say shift up by 2. Moving on here, we are graphing these functions without a calculator. So if you use a calculator on this, it's going to be very obvious. And I'm going to cross it out. I'm going to circle no calculator, and I'm going to give you absolutely nothing, right? There's no pity points. There's no partial credit. If you don't know how to do this without a calculator, you don't deserve credit. So step number 1, you're going to pick up your entire function. So everything that they give you, you're going to pick this up and you're going to copy this down. Try to write small on these, so that way you have enough space. You are at the same time going to open for x. So I'm going to write 2 parentheses. Here's my x value. I'm going to open that location for x. And these x values are going to be the ones that I'm going to write into my x location. So here's -2, here's -1, here's 0, here's 1, here's 2. Next, you're going to take a look to see if there's anything to do in the exponentials. For example, sometimes you have to add, subtract things in the exponent spot. For us, we only had just x, so there's nothing to add, subtract. Instead, I am taking a look and seeing if I have a negative. If there is a negative in my exponential, that means I am going to flip the base, make the exponent positive. I am going to flip the base, make the exponent positive. I only have 2 that have a negative exponent. Here I have 2 to the 0th power. Anything to the 0th power is just 1, so that one's done. Here I have 2 to the 1st power. Here I have 2 squared. This is not 2 times 2. This is the base of 2 written out twice. This is 1/2 times 1/2. This is just 1/2 one time. That means I have a 1/2 here. That means I have a 2 here. 2 times 2 is 4. 1 times 1 is 1. 2 times 2 is 4. What this means is we have now created points. -2, 1/2. Sorry, 1/4. -1, 1/2. 0, 1. 1, 2. And 2, 4. We can use these points to graph. Before we do that, we do need to identify the asymptote. Our equation was f of x is equal to 2 to the power of x. Remember, based off of question number 3, our asymptote is the number in the back of the equation. That's our k value. And if I don't have a k, I still must have an asymptote. So if it's missing, the asymptote is 0. You have to write this in the form of an equation at y equals. Skipping domain and range for a moment, let's go ahead and find that y, 0. And you're going to do an asymptote on the x-axis. So do not do it higher or lower. It has to be on this darker line x-axis. Extend it, it has to be dotted. This is how I'm going to know how to grade. Next, you're going to pick out the points that you can graph. So I can graph 2 and 4. Here's 2, here's 4. 1 and 2 we can graph. 0 and 1 we can graph. Negative 1 and 1/2, I mean, it's starting to become a little difficult, but I still can guesstimate where 1/2 is. And 1/4 is even smaller than that. So it looks like we can potentially graph all of our points. I'm going to do a curve. Do not, for any reason, touch your asymptote. Do not curve back up. This should not be a U. This should be an exponential, getting really close to your asymptote, but not really touching it. Here, we're going to do an exponential growth and extend back out. Now let's talk about domain and range. Domain will never change for an exponential, never change. It's always going to be from negative infinity to positive infinity. These are your x values for your exponential function. We can put any x's we want in the equation. So that means we can go from negative infinity to positive infinity. However, for your range, you're going to take a look at your graph. And you're specifically focusing on your y values. Your y value will have a smaller and a bigger limit. So what I mean by that is, here we see an arrow. This arrow is going off to positive infinity. However, this arrow right here is approaching your asymptote. And your asymptote was at 0. So what is bigger? What is smaller? 0 is smaller. Infinity is bigger. Now, if we had a neither function and it was going down, things would be different. We would have a negative infinity, but we have this here. Okay, let's go ahead and try again. Once again, if you use a calculator, credit will not be provided on the exam. Step number 1, you're going to copy the entire function. Now here, the mistake is forgetting about that 2. Don't let that 2 fool you. Write smaller here. And you're going to do 2 things at the same time. You're going to copy down the given function, and you're going to also open up for x. Again, don't forget about that minus 2, but also don't forget to open up for that x. So I'm going to write 1/4. 1/4. I'm just writing the base of 1/4. Next, I'm going to open up for x. These are my x values. And x is -4, -3, -2, -1, and +1. There is no 0. Next, I have is a +2 in my exponent spot. And then again, please don't forget that you do have that -2. Got to write it a little bit bigger so you see that it's not part of your exponent. Okay, because I have multiple things in my exponent spot, we do need an extra step to evaluate what these are. We're just adding these together. So it looks like I have a base of 1/4, base of 1/4. This base will not change in this step. And then we start evaluating what these exponents are. So negative 4 plus 2 is still a negative 2. Negative 3 plus 2 is a negative 1. Negative 2 plus 2 is 0. Negative 1 plus 2 is 1. And 1 plus 2 is 3. Don't forget about this minus 2. Write it a little bigger. Next, we're going to check if we have any negative exponents. Here I see a negative. Here I see a negative. So it looks like only 2 are negative. And remember, what does a negative exponent do? Well, it flips the base. You can write just 4, or if you want, you can write 4 over 1. Make the exponent positive. Don't forget about that too. Flip the base, make the exponent positive. Don't forget about that minus 2. Here, we do not have a negative. However, we do have a 0. And anything to the 0th power is 1. Don't forget about that too. 1/4, we write this out 1 time. Don't forget about that too. And here we got 1/4 written out 3 times. Don't forget about that too. Let's expand out my 4 over 1. You can keep it as 4 over 1, or 4 divided by 1 is just 4. So we got 1, 2 4s. Don't forget about that too. Here we have 1 4. Don't forget about that too. Here we have 1 minus 2, which is just negative 1. We can write that as our answer already. Here we have 1/4 minus 2. We can just write that out. Here we have 4 times 4 times 4 in the denominator. 4 times 4 is 16. 16 times 4 is 64. And don't forget about that too. Here we have 4 times 4 is 16. Take away 2, we have 14. Here we have 4 minus 2, which is 2. And it looks like we have 2 of these that we need to do common denominator. So I have some space here. This will look similar on the exam. I will have some space down below for you to make 2 into a fraction and create common denominators. So common denominators, I need a 4, so I'm going to be multiplying top and bottom by 4. I need a 64, so top and bottom by 64. I have 1 over 4 minus 4 times 2 is 8 over 4, which means I have a negative 7/4 here. (64) times 2 is 128 over 64. Subtract, so I have negative 127 over 64. Okay, let's go ahead and take a look at our function. I'm going to copy it down here. And I'm going to write arrows. That's where we put the answers. Our function f of x is equal to 1/4 to the power of x plus 2 minus 2. And the reason I wrote this down is because the next question is asking us for our asymptote. Our asymptote is always going to be our k value, and it looks like our k value here is negative 2. To write the asymptote, you have to write this in the form of an equation. So we have to put an equal sign. Y is negative 2. We're going to find negative 2 on the y-axis. We're going to do a dotted line on that negative 2, extend it past the axis. So we want to actually see it on the sides. Skip domain and range, even though let's actually do domain. Domain never changes, remember. So we have from negative infinity to positive infinity. Range is where we're going to take a look at our function. So let's go back here. There are certain things that I can graph and there's certain things I cannot. So I have negative 4 comma 14. I have negative 3 comma 2, negative 2 comma negative 1. Then I have negative 1 comma negative 7/4, and then 1 comma negative 127 over 64. So again, there's things that I can graph. There's things that I don't really know how to graph. So like negative 127 over 64, I don't know what that is, but I can figure out the rest of them. And based off of the behavior of an exponential, we can figure out how it's going to look like. So let's start with negative 4. Negative is on this side, and positive 14. So I have a 10, 11, 12, 13, 14. I'm going to guesstimate that 14 is going to be somewhere here. Next, I have negative 3 and positive 2. Next, I have negative 2 and negative 1. And I have these fractions. So negative 7 over 4, it's about 1 and well, I guess 3/4. So it's about 1.75. So know that you cannot touch the asymptote. Know that you have an exponential function, and with an exponential function, there's going to be a curve that happens. Let's talk about Lake Tahoe for a moment. If you're going down the slope of Lake Tahoe and you jump up a mountain and you go straight down, you die. However, if there's a slight bend in it and you jump into the snow, that means you're going to curve and you're going to approach the bottom, right? No crashing, burning. If you touch the asymptote, it's lava. Don't touch the asymptote. Okay, so this is how we look like. Half of an arrow approaching the asymptote, full arrow going away. So let's talk about what we have for the range. Range talks about your y values. Looks like we are approaching negative 2, and we're going all the way up to positive infinity. When writing range and domain, the smaller value has to be on the left, and the bigger value has to be on the right. So we're looking between negative 2 and infinity. Negative 2 is smaller. Infinity positive is bigger. Okay, moving on. We have a town with a population of 5,000. So population is people. Grows, this is our keyword, 3% per year. Write a function that represents the number of people after X number of years have passed. Okay, so what this is asking is don't solve. Okay, A is not asking for an answer. What it's asking is for the equation to get the answer. So we're going to have A sub n is equal to A sub 1 times 1. Now, this is where this keyword growth comes in, plus r to the t power. And instead of a sub n, you can use y. I am okay with that as well as your equation. That part to me doesn't matter. Next, we have a sub 1. A sub 1 is your initial value that you started with. Your rate needs to be converted to a decimal by jumping 2 jumps to the left. So what it's asking here, you can use A or you can use Y. I'll use Y. The starting amount is 5,000. 1 plus 0.03 is 1 and 0.3 as our parentheses. And then T is X because X is the number of years that have passed. This is what they are looking for. Now for question number B, 7B, they are asking you to evaluate, find the population after 3 years. Use the equation that you just written down. Y equals 5,000, open 1.03 to the power of 3 years. You're going to pick up a calculator. You're going to type this in, 5000 open 1.03, close it, caret 3, and we get 5463.635. Now, since we are talking about people, people cannot be rounded and can't have a decimal. So what I mean by that is you can't have 0.635 of a person. So we're going to cut off at the whole number, but we are going to take a look at this 6. Because 6 is bigger than 5, we are going to be rounding up to 5,464 people. And you got to give me units, otherwise I don't know what you're talking about. All right, let's move on to the next one. Moving on to question number 8. Here we are once again reading a word question, word problem. A painting is valued at $10,000, but the value decreases, so we know this is going to be a decay at a rate of 3%. So we need to convert this to a decimal, 0.03. Remember, to convert to a decimal, we are looking at, let me erase that, moving the decimal place of a percent 2 jumps to the left. Okay. A year. Write a function to represent how much the value is going to be after X years. Okay. So what it's asking you to do is asking you to, once again, write out the equation. Y equals A times open 1. It is decay, so we're going to be subtracting here. R to the power of T, except we're now putting in the information that we know. So our initial value is $10,000 for the painting. We are decreasing in value 0.03, and the time that we are calculating is in X. So they don't want us using T, they want us to use X. So our answer here is Y equals 10,000. Open. I am going to pick up a calculator. Here I have 1 minus 0.03. Make sure you have this rate converted. 0.97 is inside of the parentheses with an X as my exponent. After you have your equation, you're going to go to B. How much will the painting be worth in 5 years? So that means that our T, our time, our X is now, 5. Y is equal to 10,000. Open. We have 0.97 from our previous answer. And the quantity of years we are waiting is 5. To type this into the calculator, we have 1,0,0,0, open 0.97, close it, caret 5, enter. And we are looking at Y is equal to 8,587.340257. Now I am writing everything down to show you that money is 2 decimal places. So that's going to be our cutoff. We are going to be looking at the number after, which is 0. And because 0 is 0, 1, 2, 3, 4, smaller than 5, we are going to keep the number at $8,587.34. When you're writing your answer, you want to make sure to identify what you're talking about. So in this example, we are talking about money. Money has 2 decimal places. Question number 9. If you deposited $4,000, so here's our starting amount, into an account paying 6% interest, so we know this is our rate. And here's a key word that we haven't seen yet in this video, and that is compounded. And our compound is quarterly. This quarterly is our N value. This compounded tells us we need to use the formula for compound interest. Okay. Write a function that represents the balance after t years. So let's start out by writing out the compounded formula. A is equal to P times open 1 plus R over N, close it, caret, open N times T. A is your final answer. This is your after amount. P is your starting amount at 4,000. 1, oops, that should be a 1, not a T. 1 plus our rate needs to be converted. So if I have 6%, I'm going to put a decimal place at the end. 1, 2 jumps to the left. That means my rate is 0.06. N is the quantity of times we are compounding in 1 year. A quarter means things happen 4. So that means 4 times a year, we are going to be calculating our rate, and then we are going to raise this to the power of 4 times t. Now, all of this still has a variable of t because that's what they're wanting us to do. They're wanting us to keep this in a form of a equation. We can simplify this. Remember, if you're typing this into the calculator, this right here needs double parentheses. So I could write open 1 plus open 0.06 divided by 4. Close it, close it. Let me do that one more time, a little bit better on camera. Open 1 plus open 0.06 divided by 4. Close it, close it. That's it. All we're doing is fixing the stuff inside the parentheses. So we have, again, a growth 4, 0, 0, 0, open 1.015 caret 4 times t. And I just moved A to the other side just because I ran out of space on the other. So again, I want to be very clear. This right here was calculated to this right here. Okay, so what are they asking us to solve? Well, they're asking us to evaluate after 5 years. So that means our t is now 5. Now you have a choice to make. You can either use this unsimplified one or you can use your answer from the previous question. Either way, we are taking our $4,000. We are putting it into an account with a 6% interest rate, compounded 4 times a year, quarterly, for 5 years. If you use this unsimplified version, it's fine. As long as you have your extra parentheses, you're going to get the right answer. So 4,000, open, 1 plus, open, 0.06 divided by 4. Careful here, close it, caret, open 5 times 4, or 4 times 5, close it, equals. We have an answer of 5387.42000626. Money has 2 decimal places. We are going to be looking at the next number over, which is this 0. Because this is smaller than 5, we are going to keep that 2 in our answer. So our money value is $5,300.87 and 42 cents. Again, 5,387 and 42 cents. Okay, let's move on. Question number 10 is asking you to tell whether the table of value represents a linear or an exponential function. What this means, linear, we're going to be checking if it's arithmetic, which is a common difference. Exponential is geometric. This is arithmetic. With a common ratio. So we are going to be kind of ignoring the 0, 1, 2, 3, 4. We already know that it's increasing by 1. So we want to know how is it increasing. So these again are just increasing by 1, which is fine. We're not really looking at that. We're looking at the output. This plus 1 doesn't really tell us anything. We're looking here. And again, be careful because you're going to take your right minus your left, your right minus your left, your right. Oops, that should be a 4. Negative. Hold on. Your right minus your left, your right minus your left, your right, which is 4, minus your left, which is 0, and your right minus your left. Again, your right minus divided by, geometric, divided by your left, your right divided by your left, your right divided by your left, and your right divided by your left. Here again, you will have access to a calculator. If you want to type this into a calculator, you can. If you do that, make sure that you are still opening up your parentheses, putting a minus, and then opening up your parentheses again. This is a positive 4. Go up, go over. You can then just change your values out without having to retype everything. This is 4, 4, and then 0, and 8, and 4. Again, you can use your brain, you can use a calculator. Now, here, -4 divided by -8 gives us a decimal. Convert that to a fraction, second PRB, this is 1/2. This one here, I'll tell you 0. This is undefined. And this here is 8 divided by 4 is 2. So what is the purpose of the question here? We are asking which is linear or exponential, which means is it arithmetic or is it geometric, which means does it have a common difference or does it have a common ratio? So if we take a look here, notice that we have a common difference of 4. Because these are different, this is not geometric. I'm going to split this up so I don't take the other question space. So what is the answer? Well, you have to actually read the question one more time and see what it's actually asking of you. It's asking you to determine, is this arithmetic, linear, or is this geometric, exponential? They're not actually using the words arithmetic or geometric, so we cannot use the words arithmetic and geometric. We must use the words linear. We must use the word exponential. So the question is asking, is it linear or is it exponential? Linear means arithmetic, geometric means exponential. So because we had a common difference, our answer is this linear or geometric? This is a linear function. Okay, that's your answer. Okay, let's do it again. Again, right, left, right, left, right, left, right, left. Be careful with your rights and your left. Going to split this up one more time. And we're doing 0.6 minus 0.2, 1.8 minus 0.6, 5.4 minus 1.8, and 16.2 minus 5.4. Right divided by left, right divided by left, right divided by left, and running out of space here, right divided by left. So again, when we are subtracting, we are testing for a common difference, which is for arithmetic. When we are dividing, we're testing for a common ratio, which is for geometric. So 0.6 minus 0.2, and we get a 0.4. 1.8 minus 0.6 This is 1.2. So immediately we know this is not going to be arithmetic. This is not linear because we do not have a common difference. So I'm just going to write no common difference here. It's not arithmetic. So let's see if it's geometric. It also could be neither. It doesn't have to be exponential and or linear. So or linear. Here we have 3, 1.8 divided by 0.6. Here we have 3, 5.4 divided by 1.8. Here we have 3, and 16.2 divided by 5.4. Here we have 3. So these are the same. That means we do, yes, have a common ratio of 3. Okay, so it is a common ratio of 3. So what is the question asking us? It's asking us to choose from two things, linear or exponential. Because there is no common difference, it is not linear. Okay, not arithmetic. So for our answer, we're going to write that this is exponential or geometric. So exponential, trying to make it work, function. And this is our answer. Okay, moving on. State if each sequence is arithmetic. If yes, state the common difference. Okay, so now the difference between what we were asked and what we are being asked is if they are asking only for one specific thing. Is the sequence arithmetic? What is the common difference? So I only need to do my arithmetic test, which is right minus left, right minus left. I don't have to do geometric test here. It's not asking for geometric. So my right and my left, so -5 minus a -35. My right minus my left, so 25 minus -5. And my right minus my left, we get 55 minus 25. Again, type this into the calculator. I am going to do that. I get 30 for this one. 25 minus open -5. There's 30. And if the next one is 30, then yes, it is arithmetic. It is. Okay, so how do we know this is arithmetic? Yes. Yes, arithmetic. Okay, how do we know? Because our common difference is 30. Okay, let's do the same thing for the next one. We take our right and our left. So we got -4 minus -2. Our right and our left, -12 minus -4. And the last one, our right minus our left, -48 minus a -12. -4 minus a -2. I get -2. -12 minus a negative, oops, that's wrong, minus a -4. I get a -8. -48 minus -12. I get a -36. Now we can see that all of these are different. These, for our answer, state if it's arithmetic. So is it arithmetic? No, it is not arithmetic. How do you know? Because there is no common difference. Okay, moving on to the next one. Find the next three terms in the arithmetic sequence. So this is going based off of your common difference. We can do this by finding out the pattern here, 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 and continuing that pattern for the next three terms. Same thing here. Finding the pattern, which is arithmetic, and continuing for the next three terms. So how do you find the pattern? Well, that's your common difference. I'm going to go ahead and split this up here. Common difference would be your right minus your left, your right minus your left, and your right minus your left. We got 25 minus 17, which is 8. 33 minus 25, which is 8. 41 minus 33, which is 8. So that means our common difference is 8. So to find the next three terms, we're just going to follow that pattern. 17 plus 8, common difference, is 25. If I take 25 plus 8, I get 33. 33 plus 8, I get 41. So to continue that pattern, 41 plus 8, we get 49 as my next term. 49 plus 8, 57 as my next term. And 57 plus 8, I get 65. Okay, let's do the same thing. Let's find our common difference. We got the right minus the left. Now, how do we know that we're only checking for common difference? Well, because when it's asking us in our question, it's asking for the arithmetic sequence next. So they basically tell you you're only doing one test. You're not doing your geometric test here. Let's again find our common difference. So if in a question like this, you end up not getting a common difference, two things can happen. You either can make a mistake, and it is actually arithmetic for a question like this, or you cannot continue. Because they are asking for the next three terms, a question like number 12 will be arithmetic. It's not going to not give you answers. There will be an answer for something like this. Common difference here is -9. So even though this is negative, we're still adding that number. So we got -12 plus a -9 is -21. -21 plus a -9 is a -30. -30 plus a -9, that is a -39. -39 plus a -9, my next term is -48. -48 plus a -9 is a -57. And a -57 plus a -9 is a -66. Moving on to the next one, state if each sequence is geometric. So now they are not asking us to do common differences for arithmetic. They are going to ask us for a common ratio. Ratio is where you take your right divided by your left, and you're going to get your common ratio. So we got your right and your left, so -4 divided by 2. Your right, then your left, 8 divided by -4. And your right and left, 16 negative divided by 8. If these end up being the same, we get -2 here. 8 divided by -4, also -2. And -16 divided by 8 is also -2. Notice how all of these answers for your fractions are all the same. So that means, let's answer the question. Is the sequence geometric? Yes, geometric. How do you know? Well, we got to state the common ratio, and it was -2. Okay, same thing. Let's take our right and our left. Your right is -25. Your left is -125. Your right and your left, -5 over -25. And then your right and your left, -1 over -5. If we use a calculator here, notice that it's going to give us a decimal. We don't want decimal, so you're going to press this second right here, pre-RD, and that's going to convert it to a fraction. So we get 1/5 here, positive. -5 divided by -25, again, second PRB. We get positive 1/5. -1 divided by -5, second PRB. We get 1/5. Again, all of these ended up being the same. So let's answer the question. Is the sequence geometric? Yes, it is geometric. How do you know? Well, we have a common ratio of 1/5. Okay, finding the next three terms in the geometric sequence. So geometric means we're now going to be looking for a common ratio and then using that common ratio to continue in finding the next three terms. So I'm going to split this up, give myself some space for the top versus the bottom question. Top question, let's do our right divided by our left. So we got 50 divided by 250. We got 10 divided by 50, and we got 2 divided by 10. Let's see what our common ratio is. 50 divided by 250, second PRB. Looks like I have another 1/5 here. 10 divided by 50, second PRB. I have another 1/5 here. 2 divided by 10, second PRB. And again, I have a 1/5. So what does this mean? That means that between all three of these, my common ratio for the first question, A, is going to be 1/5. That means that I am going to be using in each jump a multiplier of 1/5. Okay, so how would that look like? Because this is geometric and we have a ratio, 250 is going to be multiplied by the common ratio of 1/5. This here is our ratio. Okay, this is our R value. Equals, well, that's our next term of 50. So now we take 50 times our common ratio of 1/5. We get 10. 10 times our common ratio, we get 2. 2 times our common ratio, and we get second PRB, 2/5 as my next term. 2/5, careful here, let's do parentheses, 2/5 times our common ratio, 1/5, second PRB, and we get 2/25. So again, we're getting fractions because we are multiplying and getting smaller and smaller and smaller values. 2/25 times my common ratio, second PRB, and I get 2/125. Okay, so what are my next three terms? My next three terms is 2/5, 2/25, and 2/125. Let's do the next one, B. Take your right divided by your left, so -3 divided by 1. Take your right divided by your left, 9 divided by -3. And take your right divided by your left, -27 divided by 9. -3 divided by 1 is a -3. 9 divided by -3 is a -3. And -27 divided by 9 is a -3. What does that tell you? Yes, it is geometric. There is a common ratio of -3. So what does that mean? With each jump, I am going to be multiplying by my common ratio. That will give me a pattern, which then will give me my next three terms. 1 times -3, -3 is my ratio, and that is -3. Right here, this is where I'm at with my finger. -3 times -3, my common ratio is 9. 9 times -3 is -27. -27 times -3 is a +81. +81 times -3 is a -243. -243 times -3 is a +729. So what are the next three terms in my geometric sequence? We have 81, -243, and a +729. Okay, moving up. For question number 15, we got A, B, and C. Answer the following questions for the given sequences. Is the sequence arithmetic or geometric? Okay, so this is how you're going to do these questions, the first thing you're going to do is you're going to test for a common difference or a common ratio. Okay, I'm going to go ahead and do this off to the side, trying to find some paper. So 15a, and I'll come back and write answers here. 15a, we have -1, comma -2, comma -4, comma -8. We have to check for arithmetic, and we're going to check for geometric. And then we have our answer. Okay, so arithmetic, we're going to take our right number and our left number and subtract them. So -2 minus -1. Take our right and our left, subtract them. -4 minus a -2. Take our right and our left and subtract them at -8 minus -4. For geometric, our test is our right divided by our right divided by our left, and our right divided by our left. If it gives you a common ratio, it is geometric. If it gives you a common difference, it is arithmetic. Let's go ahead and do this. Double negative. -2 plus 1 is a -1. -4 plus 2 is a -2. -8 plus 4 is a -4. Because these are all different, no common ratio. So this means it is not arithmetic. For geometric, negative gives us a positive. 2 divided by 1 is a positive 2. Negative gives us a positive. 4 divided by 2 is 2. Negative gives us a positive. 8 divided by 4 is 2. Because all of these are the same, yes, it is geometric. So, is it arithmetic or geometric? It is geometric. How do we know? Well, the common ratio is 2. So let's go back here to our worksheet. Is the sequence arithmetic or geometric? Well, it is geometric. How do you know it is geometric? Well, we solved for the common ratio. And that was a positive 2. Write the explicit rule for the sequence. So the explicit rule for geometric is a sub n is equal to a sub 1 times open r caret to the n minus 1 power. That's the formula, okay? That's a formula you need to have memorized. That's not the answer. This is just a formula. Okay. To actually answer the question, we got to input some things. A sub n will stay, but a sub 1 is the term in the first position. So I'm going to go back up to my given sequence. Here is -1 in the first location. That is the number that I'm going to replace a sub 1 with. So the term in the first location or the position is -1 times your common ratio is what you just solved for, 2. And then your n minus 1, you're going to keep that. This here is your explicit rule for your specific sequence. So going back to our worksheet, what is the explicit rule for the sequence? We have that as a sub n is equal to a sub 1 times r. Just kidding. We know these values. Let me go ahead and fix that real quick. Because I was writing the formula. We don't want the formula. We actually want the equation. So the term in the first position is -1 times open 2 is our common ratio, and then caret n minus 1. Write the explicit rule, or using the explicit rule, find a sub n. Okay, so now what they want us is to find a specific term. When you do this, this is the term in the eighth, position. So you're going to pick up your formula, a sub n is equal to -1 times open 2 caret, and you're going to input this 8th position as your n value. So a sub 8 means 8 is your position. So you're going to replace n with, and I'm going to replace this n as well, 8. So that means the term in the 8th position is, pick up a calculator. Let's erase that r. -1 times open 2, close it, caret, open 8 minus 1, close it, equal, is -128. Let's write that in. So a sub 8, oh, they already have that, so we don't have to write a sub 8 equals. We just write -128. And again, how do we do that? A sub 8 was equal to -1 times 2 to the 8 minus 1 power. Okay, let's look at 15b. 15b is still asking us, is this arithmetic geometric? We got -17, -15, -13, -11, comma, dot, dot, dot. We're going to be doing our test for arithmetic, geometric, and getting our answer. Again, we're doing our right minus our left, our right minus our left, and then we're doing the right divided by the left. So the right is -15 minus left. The right minus left, so -13 minus -15. And lastly, -11 minus -13. We're going to be dividing, so -15 divided by -17. -13 divided by -15, and -11 divided by -13. -15 minus a -17, well, that's 2 positive. Double negatives here, be careful. Double negatives here. 15 and -13, that is also a positive 2. And this last one, 13 and -11 is also a positive 2. These here, the only thing that can simplify are these negatives. So we still have 15 over 17. These are prime. These ones right here, 17 is prime, 13 is prime, 15 is not prime. But we cannot simplify anything here. These do not have a common ratio. But here, yes, these are the same. So this is a common difference. So what is our answer? We do have an arithmetic. And how do we know it's arithmetic? Well, the common difference is 2. So let's go back to our worksheet and answer some questions. Is the sequence arithmetic or geometric? We determined that this is arithmetic. How do you know? Well, we know because the common difference was 2. Write the explicit rule for the sequence. Let's go back here. To write the rule for the arithmetic sequence, we got to start with the formula. A sub n is equal to a sub 1 plus d times n minus 1. Again, they don't want the formula, they want you to use the formula, so we're going to be replacing some things. Looking at the given sequence, the first term is -17. That is what we're going to be replacing a sub 1 with. So now we have a sub n is equal to -17 plus, next we need to replace d with our positive 2, and then we have our n minus 1. So again, the only two things we are changing are your a sub 1 and the common difference d. Unlike geometric, you do actually need to do more. Because this is linear, we do have to distribute 2. Okay, so this plus 2 is going to go on n, and it's going to go on negative 1. This is your distributive property, negative 17 plus 2 times n plus 2 times negative 1 is a negative 2. You're going to always end up combining like terms to simplify for your final answer. A sub n is equal to 2n minus 17, 18, 19. And this is going to be your equation for your arithmetic sequence. A sub n is equal to 2n minus 19. You must always simplify and distribute with arithmetic. Using the explicit rule, find a sub 52. Which means it is the term in the 52nd position. Which means when we take our formula a sub n is equal to 2n minus 19, we are going to open up for n, and we're going to put in 52 in the location of n. This here again is a calculator, so the answer a sub 52 is equal to 2 open 52, close it, minus 19 is 85. All right, let's rewrite this one more time. A sub 52 is equal to 2 times open 52, close it, minus 19. And that gave us an answer of 85. Okay, let's do the next one. C. We get 318, 218, 118, 18, dot, dot, dot. And again, it's asking us for the same thing. Determine if it's arithmetic, geometric. So let's go ahead and do our tests, and then we have our answer. We've got geometric, arithmetic. Again, right minus left, right minus left. Don't forget that pattern for arithmetic, and right divided by left for geometric. So we got 218 minus 318, 118 minus 218, 18 minus 118. And we're going to subtract 218 minus 318. That gives me a negative 100. 118 minus 218, that gives us a negative 100. And 18 minus 118, that gives me a negative 100. Which means that we have a common difference of negative 100. Now, the trick with these is that if you already know that it's arithmetic, it's not asking you to test for geometric. It's asking you to pick one. Pick either the arithmetic or pick geometric. Because it is already arithmetic, you don't have to do this anymore. And that is because we already know it is arithmetic. Again, how do we know it's arithmetic? Well, we know it's common difference of negative 100. So this is going to be arithmetic with d equals negative 100. Let's go back into our worksheet. Is the sequence arithmetic or geometric? Again, if you know it's arithmetic, you already tested, then we do not need to test for geometric. How do we know? Well, our common difference was negative 100. To write, again, the arithmetic explicit rule, we got a sub n is equal to a sub 1 plus d times n minus 1, where we have to fill in the term in the first position, which is 318, and we are going to fill in our common difference, which was negative 100. Okay, so the term in the position of number 1, so the term in the first position is this 318, plus our common difference of negative 100. Make sure to distribute this negative 100 here and here. You have to always simplify with arithmetic. So 318 negative times n is negative 100n. Negative times a negative is a positive, so we do positive 100. Simplify, there's always going to be an arithmetic combining of like terms. So let's go and put those together to have negative 100n, positive 3. Just kidding, we are adding 100 to a positive 418. Let's write this in. Our formula was a sub n is equal to negative 100n plus 418. Again, to find a sub 30, that means they are asking us for the term in the 30th position, which means when we take our formula, we're going to open up for n and put in the number 30. So open for n, put in 30. That means the term in the 30th position is negative 100. Open 30, close it, plus 418, which is a negative 2,582. Let's write that in. Oops, wrong paper. I have negative 2,582. And again, I'm going to copy down the formula just like we did before with our position number 30. Just like that. Alrighty, moving on. Moving on to question 15D. Make sure that's it is 15D. Looks like they're giving us a sequence of negative 192, negative 48, negative 12, negative 3, comma, dot, dot, dot. Again, we are going to be testing for arithmetic geometric, see which one this is. Our usual go-to is the table of arithmetic, geometric, and then our answer. Arithmetic is taking your right, subtracting by your left. So our right is negative 48. Our left is negative 192. Our right is negative 12. Our left is negative 48. And our right is negative 3. Our left is negative 12. We'll do the same thing here for the geometric right and left, but this time with geometric, our test is to do a common ratio, which is division. Our right divided by our left, our right divided by our left, and our right divided by our left. To check to see if we have a common difference with subtraction or a common ratio with division. So let's start with our subtraction. Negative 48, open, close it, minus open negative 192, close it. Looks like I get 144. Open negative 12, close it, minus open 48, close it. We get negative 60, so we know already that this is not going to be, oops, not negative 60, that's wrong, I forgot a negative. Let's go ahead and erase that, negative 48. That's positive 36. So either way, we know this is not going to be arithmetic because the common differences are different now. Same thing with the last one, -3 minus a -12, and we get a +9. So again, no common difference. That means not arithmetic. Okay, moving on to geometric. -48 divided by -192. Again, second PRB, we want this in fraction form. This is 1/4. 12 divided by a -48. And we get a, oops, -12. -12 divided by -48. Second PRB, we get 1/4 as well. And -3 divided by -12. Second PRB, and we get 1/4. So because we do, yes, have a common ratio, that means our sequence is geometric. So I'm going to go back up here to write out the answer. And it's asking us the question, is the sequence arithmetic or geometric? We determined that this was geometric. How did we know that it was geometric? Well, the common ratio was 1/4. Write the explicit rule for the sequence. All right, since we know this is geometric, we're going to write out the geometric explicit formula. And that is a sub n is equal to a sub 1 times open r to the n minus 1 power. So that means a sub n is equal to, all right, let's go back to our first term of the sequence. The first number that I have in the sequence is -192. So we are starting out with -192 times our common ratio, which ended up being 1/4, and we keep the n minus 1. Let's copy this down. We had a sub n is equal to -192 times open 1/4 to the power of n minus 1. Using the explicit rule, find a sub 7. So what that means is you're going to take this formula here, a sub n is equal to -192 times 1/4 raised to the power of n minus 1, and this 7 in a sub 7 is going to be the term in the 7th position. So that means the 7th position means that your n value is that 7. So we're going to take our formula, a sub n is equal to -192 times open 1/4 to the n minus 1 power, which means now we have a sub 7 is equal to -192 times open 1/4. N is 7 minus 1. Now, when you're typing this into the calculator, you must have parentheses around your exponent of 7 minus 1, or you have to do it in your brain and just use the exponent of 6. So with our calculator, we're going to type this in. -192 times open 1/4, close it, caret, open 7 minus 1, close it, and I get second PRB. The term in the 7th position is -3/64. All right, let's go ahead and rewrite that here. The term in the 7th position is a -3/64. How did we do that? We input 7 for n and then proceeded to type this into the calculator, making sure to have parentheses around our exponent. Moving to the different question section, this one is asking you to solve these equations. These are going to be using your one-to-one properties and your exponential rules as well. The one-to-one property says that if you have one base on each side, so if I have a 7 here, and I also have a 7 here, these are considered 1-to-1, which means that I can remove these bases bringing down the exponents and setting them equal to each other. So 4x is equal to negative 3x minus 2. And then we can proceed to solve. So here I'm going to do a dotted line for balance, adding 3x to both sides. Bring down the negative 2, 4, 5, 6, 7x. Divide by 7, divide by 7. X is then equal to a negative 2/7. Here is another 1-to-1. We have a 5. We have another 5. So these are going to be 1-to-1. That means we can remove the 5 here, the 5 there. Dotted line for balance, bringing down the exponents on each side. We have now 2 minus 3n is equal to negative 2n. I'm going to add 3n to both sides, bringing down the 2. 3 minus 2 is just 1n, so we can say n is equal to 2. Now this one's a little bit different. This one here is going to be not 1-to-1 yet. We have to change it. So notice we have a base of 16 and a base of 64. We have to convert this 64 into a base of 16 if possible. So if I do 16 caret 2, that gives me 256, which is, again, too big. You can't get a 64 out of 256. So instead, that means I have to change the 16 and I have to change the 64. Now you have different choices. You can do different bases, whichever one works. Let's say we start at 2. So open 2, close it. And I start with an exponent of 2. Does that give me 16? No. Does that give me 64? No. I can then change the exponent to 3. Does that give me 16? No. Does that give me 64? No. Keep going. I do get a 16 here. So 2 to the power of 4. Let me erase that and write that better. 2 to the power of 4 is 16. But I also need 2 to give me 64. So I'm going to keep going. Here's 5. No, that's not 64. Here's 6. It is 64. So I can also rewrite 64 as 2 to the power of 6. Now be careful here because you do already have an exponent on the outside. This is an exponent of p. So we're going to write this p on the outside. What ends up happening before you get to use your 1-to-1 rule is you have to change your parentheses. So you're going to shift these parentheses here to the outside exponent. All you're doing is just shifting. So I get 2 to the power of 4, open, p, close it. We are kind of just bringing it from the bottom, shifting it to the top. Here, there's no exponent, so we can drop it on the outside. There's no exponent on the outside here. Okay, now, do we have a 1-to-1? Yes. Now we have 1-to-1. We have 2 and 2, one base on each side. So we can remove these 2 here and here. We get 4 times p, which is 4p, is equal to 6. Let's divide by 4. Divide by 4. Simplify your fractions. We get 3/2 for p. Okay, moving on to the next one. Notice that again, we don't have a 1-to-1. We have 25 and 5. So we got to make sure to change the base. Now, I know that if we take 25 and change it to a base of 5, here's 5, here's squared. That does give me 25, so I'm going to change 25 into 5 squared. Keep the outside exponent of negative 2x. And here we have 5 to the 4th power. Remember, when you have something like this, you've got to take these exponents and shift them. All you're doing is just bringing them up. So that means I have 5 to the power of 2, open, negative 2x. Now I have 1-to-1, so I get to remove my 5. You remove my 5. This ends up being 2 times negative 2x, which gives us a negative 4x here, equals to 4. Dividing by negative 4, dividing by negative 4. x is then equal to a -1. Okay, moving on to our next page. Alrighty, again, not one-to-one. I do have a 1 here. I do have a 3 here and a 3 here. So we need to change this 1 into a 3. And then this is not a one-to-one property because I have two bases on one side. So I'm going to need to adjust for that. Here's 3, but 3 to what power gives us 1? So if I do 3 caret 1, that is already 3. That's already 9. And you can see that the numbers are getting bigger and bigger and bigger. So instead, I'm going to go lower. So from 2, that's still too big. 1, that's still too big. 0 does give me 1. So reminder, for your properties, anything to the 0th power gives you 1. So we're going to write 0 here. Now you are unable to cross anything out because this is not one-to-one. In order to continue, we have to first use the exponential property saying, hey, if I have the same bases, I'm going to condense them by adding the exponents together. So I have 3 to the power of -x plus -x minus 1 is equal to 3 to the 0th power. Now in this step, we have 1, 3 here, 1, 3 here. These are now one-to-one, and we can continue by removing these bases. We have -x plus -x minus 1 and 0. Then we can combine these as -2x's minus 1, 0, adding 1 to both sides, dividing by -2, x is equal to -1/2. Let's do this again. I see a 5. Let's see if we can make 625 from 5. So we're going to pick up 5. And we're going to start typing in exponents to see if I can get 625, which we can. So that means 625 is now going to be 5 to the 4th power times 5 to the 3x power is equal to 5 to the -x power. This is not one-to-one. You are unable to cross out your 5s. Instead, you are going to combine by using the product property, which says that if I have two bases that are the same being multiplied, I am going to add the exponents together. Now that I have 1 5 on each side, here's this 5, here's this 5, we can remove those 5's using the one-to-one property, removing those 5's. 4 plus 3x is brought down, and -x is brought down as well. I am going to subtract 3x to both sides, giving me a 4 here is equal to a -4x. Divide by -4, divide by -4, and x is equal to a -1. Okay, 2 more on this side. Again, not one-to-one. We have 64, 16, and 64. So the smallest one is 16. We're going to check if 16 can give us 64. 16 caret 2. That's already too big. So 16 cannot give us 64, so that means we have to change things to a different one. I'm going to try randomly 4 because I know 4 squared gives me 16. So maybe if I do 4 caret 3, yes, it does give me 64. You don't have to use the base of 4. You can use the base of 2 as well. So for 64, I get 4 to the power of 3 times. For 16, I had 4 to the power of 2. And for 64, I had 4 to the power of 3. Now remember, if it has an exponent on the original, then you have to write it on the outside of that parentheses. So in this 64, I had a 2x parentheses. Sorry, in this 64, I had a 2x as an exponent that's going on the outside of the parentheses. Here for 16, I had a 2x minus 3 as an exponent. Here, I did not have an exponent on the outside. Remember, if you have an exponent with an exponent, you're going to shift the parentheses to the outside exponent. Shift the parentheses to the outside exponent. What that looks like is you're going to now have 4 to the third power, open 2x, close, times 4 to the second power, open 2x minus 3, close. Here, there is no exponent on the outside of the parentheses, so we remove the parentheses. No, you are unable to use the property of one-to-one here because you don't have one-to-one. We have two bases on this side. We have one base on the other side. This is a 2-to-1, and there's no property for that. So what we're going to do is we're going to condense. We're going to put these together by adding and bring this 2 4s into one base of 4. So 4, you can keep parentheses, you don't have to. 3 open to x, close it, plus 2 open to x minus 3, close it. And on this side, we get 4 to the third power. Now in this section, yes, we do have a one-to-one relationship. Here's 1, 4 here, 1, 4 there, which means I can remove them, bringing down my 3 times 2x plus 2 times 2x minus 3 equaling a positive 3. Now for here, you do need to distribute this 2. Here is just timing to the 2. We get 6x plus 4x minus 6 is equal to 3. Combining like terms, we get 10x minus 6 is equal to 3. Adding 6 to both sides, we get 10x is equal to a positive 9. Divide by 10, divide by 10. X is then equal to 9/10. Let me shift this up just slightly. Okay, let's go ahead and move on to the next one. We got 36 and 216. Let's check first if 36 and 216. Oh, that's already too big. So no, 36 and 216 cannot be made unless we change the base for everything. So I'm going to randomly select 6 because I know 6 squared is 36. But now I need to make sure that I can get a 216 out of, a base of 6, which is 6 to the power of 3, and 36 was 6 to the power of 2. Anything that had an exponent on the outside, like this 216, has the exponent on the outside of the parentheses. Remember that when you have an exponent with an exponent, we're going to shift these parentheses to the outside exponent. We have 6 squared times 6 to the third power, open 2n plus 3, close it. 6 squared, open negative 3n, close it. Again, no one-to-one property yet. We do need to condense and combine. Remember, if the bases are the same, we add. So we're going to condense this into 1 6 base, giving us 2 plus 3, open 2n plus 3, close it. And this is equal to 6 to the power of 2, open negative 3, and close it. Now we have 1 6 on each side. So here's your one-to-one property. And that allows us to remove our base of 6, bringing down our exponents. 2 plus 3, open 2n plus 3, close it. 2, open negative 3n, close it. Distribute that 3. We get 2 plus 6n plus 9 is equal to, multiply these, negative 6n. Combining like terms with the 9 and 2, so 9, 10, 11, we get 6n plus 11 is equal to negative 6n. And I'm going to subtract 6n to both sides. Careful here, this does not equal 0. In fact, this is negative 12n. So when we divide by negative 12 here, we're left with n is equal to negative 11/12. Okay, moving on to the next page. Looks like we have just a couple more questions left. Solve by using elimination. So these questions are from our previous chapter. Elimination is where you're going to find the term and match them together. So either the x's are going to be matching or the y's are going to be matching. So it looks like I don't have any matching x's. So I'm going to take my hand, cover this. My x's are not the same. My y's are not the same. So I'm going to choose, what am I going to choose? I'm going to choose 8 and 10 to work with. And I'm going to, let's highlight them so we know which ones we're working with. Here we go. I'm going to make 8x into a 40x by multiplying all terms by 5. So this one's going to get a multiplying by 5, this one's going to get a multiplying by 5, and this one's going to get a multiplying by 5. And I'm going to make the negative 10x into a negative 40x by multiplying all terms by 4. So this one gets a 4, this one gets a 4, and this one gets a 4. So what we're going to be solving now is going to be a new system. 8 times 5 is 40x, minus 6 times 5 is 30y, and negative 6 times 5 is negative 30. Here down below, we get a negative 40x. 7 times 4 is 28, positive y, and 9 times 4 is 36. Now that these are matching, I'm going to remove them by adding vertically. So I'm going to add these, and add these. And I'm going to write this out just once. We got 40x plus a negative 40x. We get negative 30y plus a positive 28y. And we get a negative 30 plus a 36, not a 26, a 36. So what ends up happening is if we have 40 and a negative 40, that's the whole point of what we're trying to do. We're trying to eliminate, remove the term that we've selected. Now we've selected our x's, so our goal is to remove that term. Now for the other ones, like negative 30 plus 28, we're going to add, subtract. So here's a negative 2y is equal to negative 30 plus 36, which gives us 6. Divide by negative 2, divide by negative 2. Y is then equal to a negative 3. Thinking bubble, reminder when you're doing these type of questions that this is not your answer. To continue, you either are going to choose one of your originals or one of the ones that you've created. I usually don't think too much about it, and I almost always select just the top one. So I'm going to choose this one here just because I can. Here's 8x minus 6y is equal to negative 6. Because we solved for y, I'm going to open up for y here. And I'm going to input our y value of, what it was, the y value of negative 3. Typing this into the calculator if you need to, we get 8x. Negative 6 times a negative 3 is a positive 18. And that's equal to negative 6. Subtract 18 to both sides. Bring down the 8 times x. Negative 6 minus 18 is negative 24. Dividing by 8, dividing by 8. X is then equal to a negative 3. Remember, this here is also not your answer. To write the answer, you are going to be combining both the x and the y's. So in this case, we have x, comma, y. So the x was a -3, the y was also a -3. This here of -3, comma, -3 is your answer. Okay, let's go again. Solve using elimination. We're going to select either the x's or the y's. Now, last time I did select the x's, so this time I'm going to choose to work with my y's. You could have done x's as well, it doesn't matter. But I'm going to choose my y's just to be different. So I'm going to keep my -2y. I'm going to choose not to change it, but this one, I'm going to make my -y into a +2y by multiplying. Going to put that in a bubble so the y's don't mush together. Each term by a -2. So I'm going to multiply here by -2, here by -2, and here by -2. The reason I'm going to be multiplying by -2 is because I want my symbols, my pluses and minuses, to be different in the y's. Since I am keeping the original -2y, when I'm making my change, I want to make my change into a +2y. That way we can add to eliminate. And here I have 17 times -2, which is a -34. Again, our task is to eliminate, remove. So we're going to eliminate, remove these two y's by adding vertically. Typing this into the calculator, we get -10 plus a -16, which gives us a -26x's. Here we have 8 plus a -34, which gives us a -26. Dividing both sides by -26, x is then equal to a +1. Reminder, this is not your answer. We're going to pick up one of the originals or one of your changes. Again, I usually don't think too much about it. I just picked the one that's on top. We get -10x minus 2y is equal to 8. What did we solve for? We solved for x. So that means I'm going to open up for the x value, replacing the x with the number that I solved, which is 1. Type this into the calculator. -10 times 1 is -10. Adding 10 to both sides, bringing down the -2 times y, dividing by -2. Y is then equal to a -9. Reminder, this here is also not your answer. To write the answer, we are going to, here's some space, I'm going to write it here. Open up our parentheses. The x was a 1, the y was a -9, which gives us our answer in this specific format. All right, let's move on. Graph the following system of inequality. Shade the true region only. Okay, so this one I gave you 3 different sections. I'm going to graph the actual system here. These 2 are going to be just for my work and for kind of like my idea of what the first 2 are going to look like. So I'm going to graph this one at y less than -1/2 x minus 2. This one here, I'm going to graph at y is greater than. Did I say less? I don't even know if I said less than. This is greater than -3x plus 3, and then together combined, I'll graph this here. So let's do one at a time. This is slope-intercept form. So the first thing I'm going to do is I'm going to find a -2. Here's my -2. My slope is negative, so that means I will be going down 1 over 2. So down 1 over 2, down 1 over 2, down 1 over 2, and we continue the pattern down 1 over 2. Once we are done with the one side, we're going to continue the pattern to the opposite side, this time going up and to the left, up 1 over 2. You're going to pick up your ruler, you're going to connect, and looks like, oh, there it is, my ruler. Place your ruler slightly below or above your points. And we want to extend it past the given thing. Now, because we are doing a system and a graphing of the system, we're going to immediately do this line here as well. So we're going to find the -2. We're going to go down 1 over 2, down 1 over 2. Basically, we're just copying and pasting what we did on the other graph. And this is why I'm not giving you patty paper, because I've given you these separate ones. Okay, just like that. Next up, we have a +3. It's still down because it's negative, but this time we're going down 3 over 1. 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. Okay, pick up your ruler, connect. Same thing here. Find your +3. Go down 1, 2, 3, 1. 1, 2, 3, 1. Oops, I didn't mark it. 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. And then go back. 1, 2, 3, 1. 1, 2, 3, 1. Perfect. Connect. Okay, so this is not the answer, and these are not the answers. For a system of inequality, you're going to have to shade in the true false region. So you're going to create a testing point. Usually the testing point we do is 0, 0. And you're going to put in 0 for your x and 0 for your y. And you're going to determine if that region, if this entire section is going to be true, we're going to color it in. If it's false, then the other side ends up being true. So I'm going to type this into the calculator, make sure fractions are in parentheses. So open, -1/2, close, open 2, just kidding, that's a 0. Let's try this again. Open, -1/2, closed, open, 0, close, -2, and it gives me -2. Is 0 bigger than -2? Now, some of you are a little bit confused in your positive and negatives, so you can do a little quick number line. Here's 0, here's your bigger side, here's smaller. Where is -2? -2 is here, meaning it is closer to the smaller side. 0 means it is bigger. So is 0 bigger than -2? Yes, this is true. That means this section is false. And we are going to color in the true region. Remember, for my class, we don't do scribbles, just lines as such. We're going to do exactly the same thing here. We're going to select a testing point. Let's do a testing point of 0, 0. So 0 is greater than -3. Open 0, close it, +3. Type that into the calculator. -3, open 0, close it, +3. We get 3. Is 0 bigger than 3? Again, if you need a number line, here's your bigger side, here's your smaller side, here's 0, here's 3. 0 is smaller because it's closer to the left. 3 is bigger, so this is going to be false. And we color in our true. And I'm going to do a separate color, a different color than yellow, because we're going to need to see overlapping in our next answer. So I'm going to do this in a pencil. I am going to erase the pencil because we need colors, 2 colors for our answer for systems. Okay, so for the first one, here's my line for the first one at -2. Everything above it, above that -2, was true. Here's my line for the second inequality, and everything kind of to the right of it was also true. So what we're looking at is the double section of here in order for us to indicate the color. So I'm going to again erase the pencil here in a moment, but I'm going to say this section right here and this section here is the actual true for my answers. That means nothing else should be here, only the overlapping of the colors. All right, let's do this again. Let's split this up. We got y is greater than -2x minus 1. We got y is less than or equal to x plus 2. Let's graph these 2 lines. We start at -1. Here's -1. This is negative, so we're going to go down 2 over 1. 1, 2 over 1, 1, 2 over 1, 1, 2 over 1, 1, 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Okay, let's use our ruler to connect. And we're going to do the same line here, starting at -1, down 2 over 1. And then go the other direction. Okay, let's do the second one. We have a +2. Now this one is positive. We have 1 over 1. It's a secret, 1 over 1. Because I only see one x, there is a number 1 in front of it. So that means we're going to go up and over by 1. And then once you have that pattern, you're going to go the opposite direction. Use your line, use your ruler to connect. And I believe I made a mistake. So let's go ahead and continue. Actually, let's pause here. Let's go ahead and fix my mistakes. I didn't realize. All right, let's go ahead and fix my mistakes. Let's pause for number 21. Pause for number 21. Let's fix it here. So one thing I didn't really at all realize for some reason is that these inequalities are missing something, okay? So these are just greater than, which means that we're going to have a dotted line. Notice how there is no or equals to. So on all of these right here, I need to go back and fix it and do a dotted line, not a solid line. Same thing here. Because of this symbol, we need a dotted line. And again here, dotted line for both. If you do give me a solid line, that is wrong. So that is why I'm going back and fixing my mistake. It has to be dotted for both, otherwise it will be marked wrong. And I'm happy I caught my mistake. So when we're taking a look, let's actually pause here. Okay, dotted, dotted, dotted. Okay, dotted. So if we go back here on question number 21, This one right here has a greater than symbol without the line underneath, so this one is going to be dotted. So let's dot this one here as well. Okay, let's fix that. And then this one, because of this line here, that's actually going to make it solid. So this one doesn't need a fix. We still got to do it on the other section. So let's go ahead and start at 2, go up and over 1, and the other side as well. Okay, pick up your rulers. This one again is going to be solid. The others were dotted. Now we're going to test out our regions. Let's start with this one. Testing is going to be 0, 0. Here's our testing point. And I'm just going to type this into our calculator of -2, oops, -2, open, close 0, -1. And so what we have, our testing point is 0 greater than -1. Is 0 bigger than -1? No, this is false. 0, actually, life is great sometimes. It is true. Let's go ahead and prove it for my brain because 0, here's -1. -1 is smaller. That means 0 is bigger. So yes, this is actually true. That means my other section is false. This section is true. Because that section is true, we can go ahead and color it in. Okay, let's go ahead and try this one. Testing point is 0, 0. So we got 0 less than or equal to 0 plus 2. Is 0 smaller or equal to 2? Just in case, I'm going to go ahead and do my number line. 0 is smaller, 2 is bigger. Yes, that is true. So I'm going to color that in. That means my other side is going to be false. Okay, so everything to the right of my red dotted line is going to be true. I'm going to do this in pencil, and then I will redo this in my colors. Okay, anything below my solid line is going to be true as well. So what I'm looking for is that double intersection, which is this section right here, of my two true regions. So we have this one right here, and we have this one right here. So that means that I'm going to go back and erase the parts that are not true, true. Because we want to have true for both sections, not just one. All right, beautiful people. Thank you so much for watching. That is it, a longer video. I appreciate if you stayed till the end. Thank you. Bye.